Hi, this is Ed Brokish, Extension Specialist at Kansas State University, answering the question, does ethanol burn hotter in my engine? Well, the short answer is no, it does not. But it can seem like it in some instances. And that's what we're going to talk about today. If we look at the combustion temperatures of gasoline versus ethanol, gasoline burns at 3,622 degrees Fahrenheit versus ethanol at 3,495 degrees Fahrenheit, about 150 degrees Fahrenheit less than gasoline. So ethanol burns a little cooler than gasoline. But there's more to that story, and we're going to have to talk about some background information for you to understand that story. So it all starts with the air-fuel ratio. If we look at adding fuel and air into a cylinder of an engine, we add a spark, we get combustion, water, CO2, and energy comes out. The chemical equation for that combustion looks like this. For complete combustion of ethanol, as shown here, you need to add 9 pounds of air to 1 pound fuel into your combustion chamber to get complete combustion. The air-fuel ratio then is 9. If we compare the air-fuel ratio of ethanol to gasoline, we can see that for complete combustion of gasoline to occur, you need 14.11 pounds air to 1 pound fuel for complete combustion to occur. Now, once we get in the engine, there's some variations off of this perfect ratio for complete combustion. If we have a little less fuel and more air, the ratio is called a lean ratio, and the ratio is higher. So 15 instead of 14.1 for gasoline would be considered a lean ratio. A rich mixture would be where you have a little more fuel, a little less air, the ratio is a little bit lower. So for gasoline, a rich mixture might be 12. Now, in an engine, the ratio, fuel to air ratio, is seldom chemically correct. Manufacturers often set the engines to run a little rich because they can get a little more power and they can get a little cooler operation. Now, this cooler operation that we're going to talk about a little bit today. And the cooler operation is that as you add a little more fuel, it actually reduces your flame temperature, and so you can actually cool off how the engine operates. So a rich mixture will be a little cooler than a lean mixture. Now, when we add ethanol to the mix, the ethanol molecules, as you can see here, contains a small amount of oxygen. What that oxygen does is it starts to lean the mixture. So if you have a gasoline engine operating right there at that perfect air-fuel ratio and you add ethanol to the mix, the addition of the ethanol in the mixture will actually lean out the mixture. So the mixture, the air-fuel ratio will actually be a little bit higher than what maybe the settings of the engine are. And the result can be a little engine heating or maybe some power loss. Now, what happens in modern engines is that if you add ethanol to the mix, they have computer control systems and sensors that can sense this addition of air or of ethanol to the mix, and it will adjust the air-fuel ratio accordingly to get the right mix to limit any heating problems and any power loss that may be accompanying that leaner mix. Now, it's when we go to the older engines that you start to see a problem, and if you've noticed any heating with the ethanol in your fuel, it's because it's likely in an older engine or a small engine. Why is this? Well, these older machines do not have the sensors and control systems that modern machines do, and so they cannot make that adjustment to the air-fuel ratio on the fly, and the mixture becomes leaner and you get a little heating. Now, not all is lost. If you have a qualified mechanic or are a qualified mechanic, you can make an adjustment to the air-fuel ratio and solve the heating and power problems that may be accompanied with the ethanol added to the mix. And it is just a simple adjustment. So, then in summary, does ethanol burn hotter in your engine? No, it does not burn any hotter than regular gasoline. It's really the air-fuel ratio that is changed, and that is why you might see some higher combustion temperatures with ethanol. Modern engines, you're not going to see that because they have the ability to adjust. It's the older engines, the small engines, that you could see some differences, and adjustments can be made if you do have problems with heating. This is Edwin Brokish at Kansas State University, thanking you for your time.